Hello, my name is Simon. I'm a cybersecurity engineer, an active cybersecurity practitioner. I do a lot of research when it comes to cybersecurity and network related issues. And today with me here is something interesting. This is called a four chassis motor. And before I explain this, yesterday we had an event at the ALX at the piano called the Soccerbots event. And what the event was about was participants could come up with robots or bots that could autonomously play a football match controlling a ball. And we also came up with our system, and this was our idea. So we had loaded onto this, and this is an ESP32. It has Bluetooth and Wi-Fi capabilities. So onto this we had written a code, and onto that code it had a web page, and the web page had a simple functionalities. The web page had something like this. This is a controller. It's called a controller. It had something of that sort, and we could send the Bluetooth, the signals here via the Wi-Fi connect. We were connected onto the Wi-Fi, and we had mapped it onto an IP address. So the IP address was 192.168.1. So once you are connected to this and you access the 192.168, you are able to access to get the gaming pad and control this system. So with me here is a four chassis motorboard, and this is our power compartment. The four chassis motorboard has four motors, and this system is a power hungry system. And considering our board, this ESP32 board only supports up to a maximum of 5 volts. It means you won't be able to run these four motors using this system. So what comes in? This is called an L298. Power it's a power system that feeds power hungry components like the four chassis motor. So L298 supports up to a maximum of 12 volts input, and this system probably needs maybe 9 up to 9. Standard is 9 volts, 7 to 9, but probably 12 can run also 12. So with me here is this L298, and the L298 has several inputs and outputs. So this is the power. This is where you input power. So the middle space is a negative, or it's called ground, and this is 5 volts. This is 12 volts. So assuming you are inputting here 12 volts, you place one cable at the 12 volts, the positive cable from your power supply at 12, and the negative on ground. And this system, if you're using 5, you place the positive on 5 and the negative on ground. These cables are the ones that are now connected to our ESP. So for this module to send as signal here, they are connected via these wires. And this first wire is called the ENA. This is called the in1. This is the in2, in3, in4, and this is the ENB. So the ENA and ENB are used to control the speed, and these other carry information. So the first in1 and in2 carries information for the out1 and out2. So in3 and in4 carries information to the out1, out4 and out3. So this system has only 2 power output, meaning it's supposed to support up to 2 motors. But our system had, we had twined the motors on the left side and the right side. So we had connected these motors to act as a single unit, these ones as a single unit. And maybe somebody could ask, how will they turn? So for this system to turn, these left motors will go forward and these right motors will go backward, creating a turning effect. And our system had extra component. This is called the ultrasonic sensor, and this is the NRF module. So our system had 2 modes. The automatic mode, where you use the ultrasonic sensor. See, this is a distance sensor. It could sense if the ball came into proximity with our board 3 centimeters or less. It automatically triggers this board to create an effect. And that, what was the effect? So the effect, as early intended, we have this called a servo motor. So onto this we had attached a straw, soda drinking straw onto this, so that when the ball came into proximity of 3 or less centimeters, and it activates this servo motor to push. So once it pushes, it had only a 180 push. As you can see, it had only a 180 push, so it could rotate up to 180 degrees. So that's to hit the ball. And once we realize that maybe we hit the ball and the ball has not reached its destination, that's the opponent goal, because the match was this way: ball is placed in the middle, opponents on the sides, and the goals on the extreme sides. So if we realize that the system could have not pushed the ball into the goal, what we could do is we now have the gaming pad incorporated onto our website that was stored onto this. It was accessed offline. So using the controller buttons, we could move the system onto near where the ball is, and we could either push using the board or activate the servo motor to hit the ball again. So that was our system. Unfortunately, the ESP board we were using came to a halt. Maybe I don't know if it's a permanent halt. It came onto a halt. And guess what? We got a new board. This is the ESP32W ROM 32E. So it has a debugging pin added onto it. It's an upgrade to this, and we were now coding the system to run on this, but unfortunately we were out of time, and considering the connections, uh, the the labeling is not the same, and we had to do a we had to reconfigure this the program of this onto this, and it took time, so we were not able to participate. But no problem. We'll be participating soon. They hinted at war bots or battle bots, and I'll explain that. With me here is an Arduino Uno R3. So the first time I came into contact with an Arduino Uno R3, or the Arduino Uno, was in 2018. I was at high school. I was informed to. There was a project we were doing, and the same. Actually, I was not participating. Our school was doing, so I was watching from the sides. In 2020, I was privileged enough to be doing a project with this board. So the project was a fire extinguishing system in a room, and this was mainly for industrial rooms, like rooms that store maybe hardware components, rooms that are not occupied by people. They are storage rooms. So this system had a smoke sensor, and once it sensed smoke, it could react. Baking powder with another chemical. I don't remember well. So the reaction produces CO2, and the CO2 creates a coating above the flame. So once it reduces the acceleration of the flame, since once the oxygen below is used up, the fire extinguishes by lack of new oxygen coming into it. And that was our system, but it was during COVID 2020. So Corona came in, and we never proceeded with our project. But this is the system that we were using, and probably we'll be doing a lot of projects. And considering that I hail from the cybersecurity and networking field, I'll be able to incorporate cybersecurity projects onto these boards. And my peak, I believe I want to create up to a drone. I want to create a drone. So I'm still working on this. We'll be still having our videos, and our next videos is about retrieving hacked accounts and preventing and configuring your accounts not to be hacked, or that's the two factor or things to consider, links not to tap to. So stay tuned and have a great Sunday.